Today we're going to be talking about how to conduct and design an experiment. Our learning target for today's lesson is I can explain how to conduct and design an experiment. Before we begin talking about how to conduct and design an experiment, let's review. And what we're going to be reviewing is basically what a hypothesis is and why it is important to always come up with your hypothesis first. So basically, a hypothesis is a possible answer to a scientific question. It is important to remember that a hypothesis is not a fact. A hypothesis is not a fact. And a hypothesis must be testable. In order to make sure your hypothesis is testable, you must be able to carry out investigations and gather evidence that is either going to support or disapprove a hypothesis. If you've created a hypothesis where you cannot carry out an investigation and gather evidence, then your hypothesis is not testable. And in order for you to have a hypothesis, it must be testable. And once you have your hypothesis and you've made sure that you can carry out an investigation and gather evidence, you can start your investigation. Now that we have our hypothesis, now we can test, or we can start setting up our test or investigation. And remember that your experiment must always follow sound scientific principles so that its results are always valid. The first thing we need to focus on when we are setting up our experiment is controlling variables. And variables are factors that can change in an experiment and must be the same. By keeping variables the same, you can tell which variables explained your results. You're going to have two different types of variables in your experiment. The first one is a manipulated variable, otherwise known as the independent variable, and this is the one variable that is purposely changed to test a hypothesis. So you're going to have two types of variables in your experiment, and the manipulated variable is the one that you change. Your responding variable is your dependent variable, and it is the factor that made change in response to the manipulated variable. Now that you have decided which variables you're going to use and which is going to be the manipulated variable and which is going to be the responding variable, now you can finish setting up your experiment. An experiment in which only one variable is manipulated at a time is called a controlled experiment. All other variables are kept the same, so meaning everything else in your experiment except what is being manipulated is the same. If more than one variable is changed, you will not be able to tell which variable influenced the results. For example, if you wanted to see how plants grow without sunlight, you are going to keep the plant the same, the soil the same, the amount of water that you give the plant the same, but you might put one in sunlight and one in a very dark place. So everything else is the same except for the amount of sunlight that that plant is getting. There's always a risk of introducing a bias in any experiment. And remember that this is called an experimental bias. So to make sure that we don't run into experimental bias, we are going to run more than one experiment, and we're going to have a good sample size. So we're not going to just test one plant in the sunlight to see how plants grow in sunlight. We're going to make sure there's one in sunlight, one in a dark place. Maybe we're going to have 3 or 4 in the sunlight, or 3 or 4 in the dark place. So you want to run more than one experiment or have more than one trial, and you want to have a decent sample size. Otherwise, you may introduce an experimental bias and your results will not be valid. Now that you have set up your experiment, you have to focus on how you're going to collect and interpret the data. It is almost time for you to start your experiment, meaning that you have already decided on your setup for your experiment. But there's still one more thing you have to do before you begin. And you have to decide what observations you will make and what data you will collect. So are you going to use quantitative observations? Remember, quantitative observations deal with numbers. Or are you going to use qualitative observations? And qualitative observations deals with descriptions that can't be described by numbers. Data are the facts, figures, and other evidence gathered. So you need to decide how to organize your data. You could use a chart, you could just write it down, but you have to figure out how you're going to organize your data. And then once you've figured out what type of data you're going to collect and how you're going to organize it, you can start to collect your data. So now you have ran your experiment and you have your data. So now what do you do? After you have your data needs to be interpreted. So one tool you could use to interpret your data is a graph. Graphs can reveal trends and patterns in your data. Sometimes there may be more than one interpretation of data. For example, scientists all agreed that global temperatures have gone up over the past 100 years. However, they cannot agree on how much they are likely to go up over the next 100 years. So once you have your data needs to be interpreted, and one possible way you can do this is by making a graph. Once you've interpreted your data, your experiment does not stop there. The next thing you need to do is you need to draw a conclusion. And this goes back to your hypothesis. So now that you have interpreted your data, you can draw conclusions about your hypothesis. A conclusion is basically a summary of what you learned from an experiment. So maybe from your experiment you learned that plants do in fact need sunlight to grow, because the plants in the sun grew a lot taller than the plants that were locked away in a dark space. To draw your conclusion, you must examine your data objectively to see if they support or do not support your hypothesis. It is okay if your data does not support your hypothesis. And you also need to consider if you collected enough data. So maybe if you've come to the conclusion that your data did not support your hypothesis, you might think about, well, did I collect enough data? And maybe if you don't think you collected enough data, you could run another experiment to see if that changes your results. So after you've interpreted your data, this is where you draw your conclusion and you basically summarize if your results supported or did not support your hypothesis. And once you've done all that, you've ran your experiment, you've collected your data, you've interpreted your data, and you've made your conclusion about your data and your hypothesis, you can communicate. And communicating is the sharing of ideas and results with others through writing and speaking. Scientists communicate by giving talks at scientific meetings, exchanging information on the internet, or publishing articles in scientific journals. So the last part of making and running an experiment is communicating your results with other scientists. And that's it. Now that you know how to conduct and design an experiment, you are set for the rest of the year, and you will be able to run experiments in our classroom successfully.